Okay, so you need your note sheet from Friday. Most of y'all picked one up. We talked a little bit about matrices. Matrices is a rectangular arrangement of numbers with m rows and n columns. So this here has 2 rows and 3 columns, so we call it a 2 by 3. And when we take equations and rewrite them as a matrix, that matrix is called an augmented matrix. Now we did do this one on Friday, because for us to be able to rewrite this as an augmented matrix, we need that top equation to be in the x, y, z form. So we'd say negative 2x plus y is equal to 1. Because once we get into this form, we can say that our numbers are coefficients for the top. We'd have negative 2 for x, 1 for y, and then what it's equal to is also 1. Our second equation would be 1 for x, 3 for y, and it's equal to 12. Questions on this here? Question how we wrote it. Now the dimensions would be rows by columns. How many rows do we have? 2. By how many columns? 3. And that's it. Questions on this here? We ready for the next one? The first equation, do we have it in the correct order? Well, no, because the x and y are flipped. So all we got to do is flip it back. So 4x plus 3y equals 13. Now that we have that written, what would our first row be? 4, 3, 13. Our second row, 2, negative 1, 5. And the dimensions for this would be 2 by 3. Questions on the first one? Yeah. Let's look at the next one. So this one here, we have 3 equations. But if we look at the top equation, because we need the variables and their numbers on the left side. Well, x and y are on the left side, but z is not. So we'll have to move the z from the right side to the left. But to be able to move it from one side of an equal sign to the other, we've got to add it to both sides. Because negative 2z plus 2z is 0. We do our opposite operation. On the left-hand side, we have 3x minus 4y plus 2z. So written in the correct form would be 3x minus 4y plus 2z equals 7. So our first equation going across the top would be 3 for x, negative 4 for y, 2 for z, and 7. The second equation would be 9 for x, 3 for y, z would be, is there a z? So we have to fill it in as 0 and then 3. In our last equation, we'd have 2 for x, 4 for y, negative 1 for z, and 2. If the variable is not written, there's not a number there, we have to fill it in as 0. Now, if it is written like just plus y or minus z, it is 1. Positive or negative depending on the sign in front of it. Questions on this here? What would the dimensions be? It'd be a 3 by 4 because we have 3 rows and 4 columns. Questions on this here? Are you ready for the next one? Okay. So let's look at this here. Are all 3 equations written in the correct form? Yes? So we don't have to edit anything. We can just write the augmented matrix. So what would we do first? 8, negative 3, 1, 5. Second equation. 2, 1, 4, 2. And this would be a 3 by 4. Questions on this here? That's not supposed to be there. Questions on writing augmented matrices, or do we feel comfortable with writing these? You feel good with these here? All right. Now we can solve a system of equation using matrices in reduced row echelon form. Because this here, this diagonal of 1s, when we get a matrix to this form, we call it, or we say that it is in reduced row echelon form. Okay? Now, if we put the variables back in for this here, x was in the first column. All the numbers in front of x were in the first column. All the numbers in front of y were in the second. Z was the third. And the other side was what it was equal to, yes? So if we fill it back in for the top, we'd say that we have 1x plus 0y plus 0z is equal to negative 1.4. Yes? Do we say 0y or 0z? No, we just say that that is, these are gone, so we're saying here that x is equal to negative 1.4, yes? The middle row is 0x plus y plus 0z is equal to, or really we're saying y is equal to 5.2, and c is equal to 16. So, or in other words, our solution for this is negative 1.4, comma 5.2, comma 16. And we can use the graphing calculators to turn or take a matrix, a given matrix, and put it into this reduced row echelon form. Okay? Now to do that, first thing we're going to have to do is rewrite the system as an augmented matrix. From there, we're going to have to input the matrix into the calculator, tell it to put it in reduced row echelon form, and then interpret the equation. So let's look at this first equation here. Now it is on the page, it's very small. So, yep, that's the right page. Yep. Right there, you see it above all the steps. What we're going to first do is rewrite this as an augmented matrix. So across the top, we have x plus y plus z equals 2. So that would be 1, 1, 1, 2. Our second equation would be 2, 3, 1, 3. And our last one would be 1, negative 1, negative 2, negative 6. And this here is a 3 by 4. Questions on how we wrote the augmented matrix? Okay. We're ready for the next step. Okay, first thing we're going to do is we're going to take the graphing calculator and turn it on. Got that. If you don't have a graphing calculator, I would get one. Because really that's before turning it on. You actually need one. Once you grab one, turn it on. Slide it down. Okay, we got it turned on. Okay, second matrix, second x to the negative 1. We all get a screen that looks something like this here. We got it. Now go over to edit. This list here lets us put matrices into the calculator. We're going to hit enter because we're going to edit matrix A. Now we said matrix A is a what? 3 by 4, yes? So in the top spot, we're going to put 3 and 4. I think most likely. It's already been put in for us. That's telling the dimensions. Now we're going to type this matrix in. I normally hit enter after I type each number in, because whenever you hit enter, it will move it to the next spot. So you want to type the whole thing in. First thing you typed in. We get it all typed in. Second quit. Second mode. Once you get it typed in, second quit. Second mode. Then we're going to go second matrix again, but instead of going over to edit, we're going to go over to math. Math this time. Okay. Now we're going to look for RREF. Once you find it, hit enter. Then we're going to go second matrix and hit enter, because this here is letting us put the matrix in that we want to work with. We want to redefine. Okay. So you find RREF. So control up or down. Mm-hmm. Yep, hit enter. Then second matrix. Mm-hmm. Second matrix. Mm-hmm. And then we want to put the matrix A in, so hit enter. Enter. Questions? Once you get that there, hit enter. Did we all get a matrix E that looks something like this here? Yes? So, top to bottom is the answer. -1, 1, 2. As we saw in the previous one, since there's, because it's x, y, z, so 1, 0, 0 is x, 1x plus 0y plus 0z. So it's just telling us x equals -1. The middle one's telling us y equals 1, and the bottom row tells us z is equal to 2. Questions on how we did this here? We're ready for the next one. First steps. So we would write the augmented matrix. I would make sure that the equations are in the form x, y, z. And as we see here, x, y, z, x, y, z, x, y, z, all three are in x, y, z form, yes? So what would our first row be? -1, 15. Second one would be 3, -9, 9, -12. And the last one, 4, -3, -1, 19. And it is still a 3 by 4, yes? Okay. So let's grab the graphing calculator. First thing we're going to do is what? Second. Then over to edit. And we can still pick matrix A because, again, we're only using one matrix at a time. We'll say it's a 3 by 4. And this time we're going to put our new numbers in. Once you get them all typed in, we're going to go second quit. Is everybody able to get them all typed in? Yes. Yes. Second quit. Once you get them all typed in, second quit. So second quit. Second matrix, we're going to go over one and we'll want to find the RREF. Once you find it, hit enter. Because that's telling whatever matrix follows this, we want to get in reduced row epsilon form. Second matrix A, since we put it in as A. And then hit enter. And hopefully you got something that looks like this here. Yes? Not quite. So 2, 3, -1. Yeah, because the sign. Then 3, -9, 9. Yeah. Yep. It's funny how one sign changes everything, yes? Questions on how we do this here? Can we see another example of one of these? Yes, sir. Huh, that's interesting. Second, quit. We'll quit out of it. Questions on any of this here? So we feel comfortable with doing this, yes? Because that's the last of the lesson. Now, I have some pre-programmed in, second matrix B. If we look at this matrix C here, we notice that the bottom row is all zeros, yes? So that's telling us 0 equals 0, so there are infinitely many solutions. If the bottom row of a matrix C, after we put it into reduced row epsilon form, is all zeros, it means there's infinitely many solutions. Because the top row, 1, 0, 1, 5, is saying that x plus z equals 5. That's an equation. We can find that in terms of z. The middle equation, 0, 1, 1, 5, is y plus z equals 5. We can solve that and get it in terms of z. We do have two equations that we can define the infinitely many solutions by. I'm going to replace B with matrix C. Now, if we look at this here, the bottom row is 0, 0, 0, 1. That's telling us 0 is equal to 1. This is no solution. No, you're good. So this here, if the bottom row is all zeros, but the last column is 1, so we have 3 zeros and a 1, it is no solution. Make sense? And that's it. I'm going to give you the rest of the class time to work on the assignment. Because, again, we do have the graphing calculators. Y'all can work on those, do those there. Now, 3 through 8. 3 through 8. Problems 3 through 8. You are writing the augmented matrix and stating the dimensions. 3 through 8. Write the augmented matrix, state the dimensions. 11 and 12. There's an error in writing the augmented matrix. So you want to state the error and fix it. I would definitely use a piece of paper on this. I do have extra notebook paper, but I would use a piece of notebook paper for this whole homework set, because trying to write these augmented matrices in the spaces is going to be a little tight. If you don't have notebook paper, I do have some by the door. So 11 and 12, figure out what they did wrong in writing the augmented matrix, state it, and then fix it. 13 through 19, odd. So 13, 15, 17, and 19. Use a graphing calculator to solve the system. I would make sure I would get at least those done before we head out, so that y'all can use the graphing calculators.